Hello again. So in this video what I'm going to do is do an example of converting from hexadecimal to decimal. So to start, I have all the digits, all the digits that we could have within the hexadecimal number system. And again, just to remember, we use the digits from 0 to 9, and then for like 10 all the way up to 15, we use A, B, C, D, E, and F. And again, that's because, 10, 11, 12, those digits use two of our hexadecimal digits, so it might be confusing as to what digit we actually mean. So here we go. What I'm going to do in this example is I'm going to convert the number A7F, okay, which is a hexadecimal number, into decimal. And the way we're going to do this is we're first going to take each hexadecimal digit and make it into a nibble, and then we're going to take those three nibbles that we have, put it together into one big one big binary number, and then convert that to decimal. Okay, so here we go. To do this, I'm actually going to just spread this out, so I'm going to write it again, just with the letters a little bit more spread out. Okay, so our first step here is, like I said, converting to nibbles. So first of all, I know that A is representing 10, so I'm just going to write that. 7 is still 7, and F in this case represents 15. Okay, and now what I need to do is, I know a nibble is 4 bits, so I need to represent this decimal number using those 4 bits. So I'm going to have my boxes again with 4 spots in them, and again this is 1, 2, 4, and 8. And so here we go. So 10 in binary here would be 1, 0, 1, 0. If I were doing 7, again this would be 1, 2, 4, and 8. It would be 0, 1, 1, 1. And then finally 15, that's actually the biggest number we can represent with 4 bits. So I actually will use all the bits here, so 1, 1, 1, 1. Okay, so there we go. And so our second step is now to combine this all together into one binary number. So I'm going to make this huge table here that has 12 slots in it. Okay, so 6 on this side, 3. Okay, and then, like I did before, below it I'm going to have the powers of 2. So we have 1, 2, 4, 8, 16, 32, 64, 128, 2, 56, 5, 12, 10, 24, and finally 20, 48. Okay, and then what I do is, in this order, because I want to keep that order, I'm going to put the digits into my big binary number. So here we go. So we got 1, 1, 1, 1, and then we got 1, 1, 1, 0, and then 0, 1, 0, 1. Alright, and our final step here is now to figure out which numbers we used. So in this case, it's anywhere where there's a 1. So I'm going to be using this number here, this number here, this number here, and so on. Okay, and I'm going to add those all up, and that'll give me what actual decimal number was represented using those digits there. So I'm going to write this out. We get 2048 plus 512 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, and that would give me my number 2,687. Okay, and to tell people that that is actually a number in decimal, we have a little subscript 10, because the decimal number system is a base 10 number system. So there we go. Thank you very much.